Hi. We have air conditioning and a cat on this day. So, hope you aren't too concerned about the audio quality. Let me, as usual, get this link shared up on the Twitter that nobody looks at. Oh god, and hopefully desktop audio should be muted because I'm hearing myself right now. And hopefully you are not. Oh, cat. Anyway, twitter.com. Let us print some text on a NES. NES? NES? What do you guys say? Because I don't know. I didn't grow up with an NES, so I got no opinions. Evening, wereworm, ververm. I'm just going to say both every time, because I know they're both wrong. But good to see you. Hopefully, you can't hear any music either, or any kind of desktop audio, if I set things up right. Get this out of the way. So, here's the thing, is I keep saying I'm not going to. Sorry about all the bonking. I keep saying I'm not going to, but yet again, I did a bunch of stuff off stream because I was curious. The cat is tenacious today. Oh, oh, buddy. I can tell you in advance this is going to be a problem. He wants love. He deserves love, and at this moment, I cannot give it to him. Anyway, so what did I do? Well, the first thing is just silly and fun, but also proves a little bit more about the work that I was doing last time, that it was working and all. It was pointed out to me on a comment in the last video that I actually, so this is not going to be right because I have been putting a bunch of garbage in here. Let's just get rid of this. That I actually, what was I doing? Oh, well, it doesn't matter now, but I was loading 1 into the accumulator without the hash that indicates that it's an immediate load. So I was loading out of the 0 page, which is very true, cat. Please stop. I love you, but now it's not the time. Anyway, so it was kind of by fluke that I happened to have a 1 in memory that was getting written to the controller output register last time and making things work the proper way. So probably got lucky there, but I was screwing around today and did a little bit of, firstly, let me shift this around. I was looking at the cart layout, like the MMC3 mapping, and that fixed bank at the end starts at E1000. I had it set to C because there is also a bank before that. There's 2 8K banks right next to each other, and I was testing to see if I could go all the way up to C1000 and not have a problem with this ROM, and I didn't, but I think that's also a fluke because that one from C1000 to E1000 is swappable by the mapper and can not necessarily be there on startup. So for now, I guess I will just stick at E1000 because that's still 8K, which is a lot to work with right now. But the other thing, the main thing that I was really screwing around with was, if you recall at all from the last session, this code is quite different. And what I've changed it to is it still does clears the interrupts, makes sure decimal mode is off, which is like it does all of its calculations in BCD, if you were wondering what that is, and we don't want that. Clears carry for the branch carry clear over here. And then in this loop, what it's doing is it's reading the controller 2, so 4017 is the controller 2 input register, and if you read from that, it'll give you, it actually gives you the current status of the data pin and also automatically clocks the clock line. So every time you read it, you read the next byte from the shift register, or next bit from the shift register. But Also, if you're just poking it with a wire, it'll just keep reading whatever value you have the wire at. We'll get to that a little bit more. And then probably not necessary, because I think the right register for outputting the strobe value only even is reactive to the very lowest order bit, but I'm ANDing it with one anyway. And then taking that value, and I am storing it right back into the latch register, which is shared by both the controller ports. And before, if you missed the last episode, the test ROM that I had written, which is the first code we got running on this thing, so that's super cool, we're making progress, it was just turning on the strobe pin. So it's the output on the controller port that normally latches all of the button states into the shift register that's in the controller. And yeah, so it defaults to off, it looked like universally, and so I just wrote a program that turned it to on, stuck an LED on it, and it appeared to work pretty okay. But, you know, I wanted to be more convinced myself, so what this will do is it'll just keep echoing whatever is on the data input pin for controller 2 onto the latch output pin forever in a tight loop. And I guess I can go through the rigmarole just for fun of assembling this and downloading the binary. Let me make sure my label is right. Yes, okay, I was using a label here, so that should automatically adjust. Cool. And yes, I will switch to using an actual proper assembler as I get further into this project. I'm just not quite ready for that yet. Anyway, assemble. Download binary. Standard binary. Generate. Save link as... I'm just going to save it over the one that I already had here. Echo controller status.bin. Yes, I would like to replace it. And then I'm just going to do the same thing that we've been doing. Open up the programmer software. Load that file, which is 64 kbytes, so I need to offset it by 64 kilobytes because my EEPROM is 128 kilobytes. It's already set for this, but I guess I will reselect it. And we will load that into the buffer here. And you should see at the end, there's our boot vector, E000. And then, just trust me, at E000 there is some code. So, I mean, it's already on here, but you know, I adjusted it slightly so that it's at the code starts at E1000 hex now. So, you know, that's some change. So, I'm gonna pop this guy out, and it's fallen. Hello. Good enough. Yeah. Pop this guy out, put it in the programmer, program it, show you that it works. So that was a fun little thing. Just took me a couple minutes, but was totally worth playing with. And I'll tell you, you're about to see it, so you don't have to take my word for it, but it works, which just reinforces that this stupid little repro hack thing of mine is actually doing shit, which just blows my mind. It always blows my mind. With digital electronics in particular, it's like things don't work at all, don't work at all, don't work at all, and then suddenly, out of nowhere, they work perfectly. And that is a satisfying feeling. Okay, EEPROM is in the programmer. And I shall program. Program. Programming. Verifying. Succeeded. And we will pop this bad boy back in. We'll see how many cycles it takes before this rickety adapter socket thing of mine just gives up the ghost. But so far, so good. I'm amazed it works, but it does. Okay. Get that in there good and tight, and then we'll probably need to adjust the cart a few times I found that it's mostly the cartridge fingers themselves that are, like, the socket itself, no problems, really. That pretty much works. It's that you have to adjust the fingers making contact in here, which I guess, you know, that just makes sense after years of experience, you know, adjusting cartridges and plugging them and unplugging them to get them to work properly. That tracks. Okay, so we've got our weird little test situation here, wired up to a controller port. 2 LEDs, one of them is just attached to power, and the other one is attached to the output of the strobe pin, as described. And I'm going to try and put these someplace where you can see them. Things are really messy. I'm going to have to clean this up in a second. And also, it's all just bare connections, so... Okay, I think that's probably good enough. And I'll get this working first, and then I'll try and turn it towards the camera a little bit better, so that you can actually see me poking the thing. One thing to note, this is a thing that took me a while to figure out, and I thought things weren't working. There is a pull-up resistor on the data pin inside of the controller port, that's not that crazy. But then there's an inverter before it goes into the register. So what that boils down to is that in order to see any change on here, in order to see a logic 1 actually get read out of that register, I can't poke it with plus 5 volts because plus 5 volts is the default level because it's pulled up, and that is inverted to a 0. So I had to switch to ground. I could not figure that out for a while. But apparently that's a thing. So anyway, let's turn this thing on and see if it's working. If it's working first try, that would be dope. Oh, it is. Nice. Nice. So, yeah, that's me poking the data pin with a grounded wire. All right, let's see if I can turn this towards you without upsetting things too much. This video cable is definitely getting in the way, and I don't need it right now. I know you believe me. I know you do. I just want this to be no tricks. Okay, so you can see that, right? Boy, what a gangle of bullshit. Okay. You can see those, right? Yes. Well, that's not all that much more visible, but... Do you believe me? Oh, one more fun thing on this. I was playing with this, so for no good reason I decided, hey, let's turn off the... let's re-enable the lockout chip, just cause. And remember, I removed the lockout chip from the Mario board just to prove that the lockout stuff is working, even though it doesn't matter at all, because we'd be using this Mario board. And I was just curious to see, I was like, nothing should happen, right? So here's the fun thing. It works for a second, because... Okay, I don't know if you can see that. Yeah, you can hopefully see. It's blinking. Because I didn't realize... I mean, I guess it makes sense. I realized the CIC chip resets when it doesn't get the handshake between the cart and the system. It hits the reset line on the CPU at 1 hertz. But what didn't really occur to me is that implied in there is that the CPU is running code when it's not being reset. So it works great, and then it gets reset, and then it works great. I just thought that was kind of funny. Hello, Ocelot. Good to meet you. I'm not sure I've seen you here before, so welcome, welcome. Today, we are talking about all of the stuff that I did off-screen, like a jerk, just to further prove that this mangled amalgamation of IC sockets and an EEPROM are working miraculously. But the goal for today is, well, here, 1 second. So I ended up making a Discord that nobody is on. My friend Aaron is on, and whoever this is, which, I mean, I appreciate that. But of course no one's on here. I didn't expect anybody to be on here, because whenever anybody asks me, are you going to make a Discord, I say, there's not going to be anybody on there. And there's not. But, you know, maybe this will build up with time. I don't know. But, firstly, I figure I'd just share this because I can. So let's drop this in chat. And here you go. If anybody wants to join the Discord, it is in chat. You can hop on in. And another fun thing about that is, you may know if you watched earlier streams, I was trying to stream my turntable over VLC in the past, and my internet connection is so crap that it wasn't great. Like, it worked okay, but like when my connection got interrupted, everyone would have to refresh, and it was a bad time. Hey, I don't know which person is Psy Guy, but good to see you. We will use the standard Peach Guy thing. But anyway, I didn't realize my Spotify, maybe I linked it to my Discord at some point, but it's linked. So instead of using the turntable, which is cooler but more difficult, if you have Spotify, which I realize in and of itself is a bit of a hump, you can come over here and there's a listen to what I'm listening to button. So right now I am listening to Twoism, the first Boards of Canada album, which is some good old-fashioned IDM stuff. Kind of Aphex Twinny, but more fuzzy and nostalgic. So that's that announcement out of the way. Oh, right, I was led here because I popped a poll on here that I knew there wouldn't be anyone around to, you know, interact with, but I did it nonetheless, and I figured I could start, one of the things on the Discord is I could start polling people for what you want me to do next time, because there's a million tasks to do to try and get this stuff done, and I have to choose a route through it. So the choice was between get started on fixing up the keyboard and getting a keyboard working on this, or start working on the text output. And my friend Erin, who I don't know if even watches this, I think she only is on here because I posted it to Twitter, and she is a Twitter friend. She voted we go for the characters. So let's go for the characters. Which brings me to the other thing that I was working on the side, like a jerkhole. Because I knew it would be a bit complex. Oh, I closed all of this stuff. So I got myself a copy of FCEUX, which is the generally recommended NES debugging emulator. And I'm figuring I'm gonna try and find the character set in the character ROM this way instead of trying to do it on the hardware, because I don't even know. There would be a way, but it would be complicated. So I'm going to do it through the emulator, and then we will use the knowledge gained there to write code to make this do more things. But for starters, so I have a copy of the Super Mario Bros. 3 ROM here. And let's see. Camera. Right, so let us grab the hex editor and the PPU viewer. I think those are going to be my main guys. And I was playing with this a little bit earlier, so I have a plan of attack is what I was working on. So I know one of the pages or banks or whatever in the character ROM has some characters in it. They're not, so there's definitely the Latin alphabet, upper and lowercase, that are pretty much in order in one of the spots, but that's it. And I'm gonna need like as full of an ASCII character set as I can pull out of this thing. So this is still going to be a little complicated because of that. But the first thing is, I know it's in there. I have seen it. And I figured out what address it was at earlier, but I have forgotten, and I need to do it over again. So I will show you my approach to how I was doing that. Let us see. So, the first complication is, you can see here, this is the view of these kind of two panes here are the entirety of patterns that are available to the PPU right now. This is the stuff that is in the character ROM, which you might think this does not look like a lot, especially for a game that has as much graphics going on as Super Mario Bros. 3. And that is because this is not everything. That character ROM that's on there, the mask ROM, has, I think it's 128K, even though the PPU address space is only a few, like 8K or something, maybe less. And that's, the mapper chip also handles that stuff. So it is constantly, you can actually kind of see up here in these two keep changing because the mapper chip is swapping out pages of the mask ROM. So, yeah, not only do I need to find out where it is in memory, I need to use the mapper chip to map that section of memory into the active PPU pattern space so that I have access to them. So, oh, it didn't occur to me that this is going to be extra fun. Thankfully, so I've been reading more on the MMC3, that is the mapper chip that is in Super Mario Bros. 3, and trying to understand it a little bit better. And basically what's going on is, we've seen this a few times, but before we were looking at the CPU banks, which is why I was saying this one is fixed. That's why I was starting my program at E1000. Theoretically, we could start it at C1000 if we make a little stub in the E1000 area that makes sure the mapper has this mapped in and then uses that. I mean, really, we could use this whole area, but if we need more space, that's probably the first place to go. But for the PPU, what is going on here is, what this is saying is that in PPU address space, there is a switchable bank that the mapper controls from 0 to 7FF, from 800 to FFF, from 1000 to 13FF, from 1400 to 17FF, from 1800 to 1BFF, and from 1COO to 1FFF. And the thing that I didn't really understand reading this that I understand now is that, so there's a section on the bank select registers. So what you do, that I finally sussed out, is you write a command to this bank select register, which is at 8000, pretty much where it is. And these bits are pretty ignorable. These ones are important. You write what register you want to write to. And that register basically means which of those switchable banks are you selecting. So you can see register is 0 through 5 are all of those character banks that they were talking about. And again, like, I got, okay, cool, but like, what is swappable into that area, which area of the ROM? And it's actually, it's way more flexible than I was thinking, which is, I was thinking too small. What you do is you set, you say, I want to set what memory gets mapped into this space. And then subsequently, you write to the bank data register, and this actually controls, you can set it to any 8-bit value, which, like your top few bits probably aren't used because there's not that much ROM there. But these just control what the top bits of the address that will get mapped to that area. So, for example, I'm bad at describing things, but perhaps by example it's better. So if I write 000 to this bank select register, that is selecting the PPU memory area from 0 to 7FF, right? What will happen is, like, let's say I then write 0 to the bank data register. That will map 000 to 07FF to 00007FF on the actual physical ROM. If I set it to say 1, then my mathing is going to be off here. I've already forgotten like how the offset works, but it'll be something like it'll map, like 1,000, let's say, if that's the offset, which I can't remember, but it might map 1,000 to 17FF, or if I write a 2 there, it might map 2,000 to 27FF to this space. How many computers do I have in my collection? Fewer than you might think. You want to just talk about the vintage ones, or all of them? Not that I have very many newish computers, but like I have my work laptops, and like the streaming computer that I'm using here is a relatively new workstation. But like just around me, let's see. Windows 98 PC, Windows 2000 PC, Tower Power Mac, the VAX way down at the end there, Apple II, Apple IIc, Apple II GS, Macintosh 2, Macintosh 2 SI, Macintosh Quadra 700, iMac LCD, Atari Mega ST, Atari 800. That is all of the vintage computers right here. So what was that, 13? So my permanent collection right here is about 13. Oh, and I have the 2 SGIs I have over there, so 15 right here. Around the corner I have some other non-working old Macs, some stuff. Like I might have another 5 computers over there. So it's not that crazy actually. Like I might have 20. And pretty much all of them are complete. As you can see, like all the stuff over here like have monitors and peripherals. This is all the usable stuff that works. So yeah, that's the whole collection. Right. So anyway, I was gabbing on and on about the mapper, but that's the complication here, is that I have to use these controls to map a chunk of the character ROM into basically available, visible video memory. So I was just, this is why I was saying, now that we've reviewed that just a touch, so you can see like, as this is switching, as it's running the intro, like just this block up here is changing. And that is because you can see some of these are 1 kilobyte chunks. There are actually, so there are two 2 kilobyte switchable banks. And those are these ones on the left side. You can switch the first and second half of this area. So this total area is a 4K window. 4K? Is it really? Anyway. Maybe. Anyway. So you can switch 2 halves of this independently, and then you can switch 4 quarters of this side independently. So that should hopefully give me enough laterality, going back to the main issue of I am pretty certain, having scanned through some of the character ROM, there are definitely some sequential Latin alphabet characters. Maybe hopefully there are also sequential numbers. And then, like, we'll see what kind of punctuation there is in here, because I'm sure they only included what they needed to. And then we have to hope that we have enough flexibility mapping things that I could map all of the characters I need at the same time, or because I can't just switch the mapper for like a number when I need a number and a character when I need a character, because it swaps everything for everyone. It swaps everything for the whole screen. So now all of a sudden, like, my characters, if I switch to the page that has number characters, then the letter characters that I wrote down before will be pointed to totally wrong patterns, and they'll be garbage all of a sudden. So I have to make sure I can actually swap them all into the PPU's address space at the same time. So that will be fun. But anyway, Let me... So what I was doing earlier to kind of figure this out in a ham-fisted way that only a person who doesn't know what they're doing would do was, of course, using this browser-based editor again, or assembler, and writing some simple code. So the FCEUX has this hex editor, and if you switch to viewing ROM file, which is kind of a weird view because it includes the 16-byte header, which is not actually part of the ROM chip. It's like this is literally the ROM file laid out sequentially in memory, which is not the same thing as what you have on the cartridge because it includes this header, which is not on an NES cartridge. It's only for emulators. It tells it what mapper is being used. It tells it how big the program ROM is and where it starts, how big the character ROM is and where it starts. So one of the funny things is, mainly because you've got this header there, all of the addresses are off by 16 bytes. So that's interesting. But we knew that the end, because of the size of the mask ROM for Super Mario Bros. 3 is 256K, we know that it extends from 0 in here to 40,000 hex. Which means, since that bank, the MMC3 always maps the very end of the mask ROM into the last 8K of 6502 address space, that means we can pretty easily find our boot vector, because it will be at... There is definitely a go-to address, and I am not using it because I am a fool. Go-to address. 040000. There we go. So you can see, this is, I was saying everything is off by 16 bytes. So you would think that pay attention up here to the title bar of the window. You would think that it would go up to 3FFFFFFFFFFF, and then 40,000 would be where the character ROM starts. No, we're still in program ROM because of that 16-byte offset. This is where character ROM starts. And by that dint, so this is our boot vector, because the boot vector is the second to last word in 6502 address space. So our boot vector is FF40. And that is close enough here that we can just go back to it. But if you'll notice, so 3, ignore the 3, FF40, because of course this first byte of the address is going to be the bank switching part of it. So we're ignoring that, because we know that this will still be mapped in at the end of memory, so it will line up. Anyway, FF40 is all Fs, which doesn't really look like valid machine code, because it's not, because that 16-byte offset, this is the beginning of code. Well, the beginning of the entry point. So this is where we can start just overwriting stuff to inject our own code, and when we reset the emulator, it will hit this boot vector and then just start executing here. So what I was injecting there was, let me remember what I was doing. So load A, let me make sure I actually properly load immediates this time. So I'm going to load 00 into A, and I'm going to store it into 8000, because 8000 is the bank select register. So you're right there, and I'm using the value 0 because I'm going to select register 0. I'm going to set the mapping for this first area of the PPU memory. And these flags I kind of don't care about, so I'm just going to set those to 0 too. So like this one is nothing on the MMC, so it doesn't even matter. This is program ROM bank mode, which does stuff that I also don't really care about. 0 is a good default value. 0 fixes C1000 to DFFFF to the second to last bank, which is the thing I was saying where if we fix that, then we can move our code all the way up to C1000 in our ROM if we make a little startup code that really just writes 0 to this. But anyway, that's all that controls. And then there's this CHR A12 inversion, which honestly I don't really know what it does and I don't care. So I'm just going to write 0 to that as well, because like that controls... Oh, I think it's like you can either have, like I was saying, how you can have 2 swappable areas on this side and 4 on this side. I think it swaps, so you can have 4 on this side and 2 on this side. But anyway, I don't care. The default is fine. So anyway, back to the code. So I'm just going to write 0 to there to select register 0 and not care about any of the other stuff. Then I am going to load some arbitrary value, is what I was doing earlier. And I'm going to store that to 8001, which is the bank data register that I was talking about before. So this will write a 1 here, and it will map the first bank of the character mask ROM into this area of PPU memory. So that'll be, it's, 0 base, so it'll be the second block of memory in there. However big those are. However big those blocks are. Right, so that will switch that first one to page 1. Then I found the last thing I need to do is the classic. Clear the carry bit and branch. Oh, wait. Clear carry. And then branch carry clear to halt loop. Because if I just run this code and like set a breakpoint after this, the emulator actually won't update its display of the PPU, which is a little annoying. But what you gonna do? So this was my little testy code that I played with, and I figured if I cycled through the banks, I would eventually find the one that I wanted, and that will tell me what bank I need to map to get those characters in there. So now that I have built that, I can just steal this code that it generated over here and manually write it into memory from that entry point. So A9 00 8D 0080 A9 01 8D 01 8018 90FE, and let's just put some zeros in for good measure, even though they don't matter. So now, and I can also get away with not having a lot of other initialization stuff because the actual Super Mario Bros. Code initialized a bunch of stuff for me, like palettes and whatnot, so it gave me something somewhat useful to work with. I would have had to initialize the PPU and do a lot of other stuff if I wasn't doing that this way, but this is what I settled on, and it worked pretty good. So if I do NES reset, we get a blank screen, and you can see this area is now mapped to a totally different thing. And if we, because I know, so A9 is load A, so this is the first load A, this is the second load A, and this is where it's loading the bank number 1. So if we just like put an arbitrary number in here, I don't know, 40? Come on. 40. It's not a very great hex editor. Let me make sure that didn't screw up my code. A9 01 8D. No, we're good. And if I reset it again, there we go, different bank. But this would have been a huge pain in the butt, and I already had a tool, if I can find it, for viewing character palettes. And I had also found another tool for separating ROMs into their character ROM and program ROM images. to make that a little easier. But, let's see. YY character. Yeah. So I was using this guy. I was actually using this a while ago. This was not just today. To kind of snoop through this program ROM or the character ROM and try and find some text characters. And there are some. Somewhere. Bear with. They're surprisingly far into the ROM. There we go. But, so I had known this was here for a while, but I was like, I have no idea how to convert this into, like, actually being able to look this up and send some valid value to the PPU that would say, hey, give me this page of stuff, and map it into memory, and I want to reference the A pattern that's in here. All very unfamiliar stuff to me. But I finally figured out, once I read, understood some more about this mapping stuff. So down here, it gives you the address of the current, like, chunk you're looking at, kind of the range. And so 017B00 is... Oh, I don't want to do that. Whatever. Is where this chunk starts at. And I know, because I read somewhere, that the chunks that, well, I guess they're 1K chunk, or the 2K chunks, right? Because 1K is 200 hex, right? Yes, that's how that logic works. So 200 hex, no, that's decimal 512, that's half a K. So actually, whoop, clear. Yeah, 400 hex is 1K. Right. So if I divide this by 1K chunks, that will give me, like, the chunk number in here, basically the bank number offset into memory is the thing I finally figured out. So if I take this 017B100 number, clear, 017B100, and divide it by 400, which I'm sure I could just do by a shift as well, gives me 5E. So let's drop that into my hat code here. 5. Oh my god, this hex editor is not amazing. Sorry to whoever wrote it. I'm sure you worked hard on it, and this is a hobbyist project. It's not like anybody makes money on this, so sorry, but it sucks. Okay, so we've got it set to 5E, and let us reset again. Let me make sure that the PPU viewer is visible. And reset. Boom! It took me a little while to figure out that simple thing about the math, but now we've got, like, I'm going to have to write PPU initialization code, but we've managed to map in the part that has the characters. So that's cool. That's something. And that's kind of as far as I got. So I am going to take a quick sip of water. Review chat. So, what characters is code page 437? I realized reviewing one of my videos the other day, I should probably read the chat questions, because if you're reviewing it, you're like, I mean, I guess you can look at the live chat, but whatever. Dirt Piper says, can you squeeze code page 437 in there? And, let me Google that. I'm sure that's a hilarious joke, but I can't remember what code page 437 is. Oh, it's just the IBM PC character set. Yeah, I don't know if they're going to have the block drawing characters in there. I gotta be honest. I am going to check my Spotify really quick, because it just decided to play something else. let's just play a different Hordes of Canada. A reminder, it's right there in chat, but I guess I can paste it again. You can see it easily. But for anybody who has joined since I first said it, there is a Discord now. There is a join link if you want to join. The main thing that I would say about it is... Oh, Ocelot's in there. Nice. Let's wave hi to everybody. Oh, and Dirt Piper. Oh, he's actually online. I've been assuming you're a guy, and that's kind of dumb. Alright, this has decided that I am not playing Spotify, and I'm in fact playing FCEUX. Good. Good. That didn't work well at all. So I was going to say, the main thing here is that I like streaming the music, and apparently you can share your Spotify that you're currently listening to with people, but not when you're running FCEUX. So, never mind, apparently. Alright. So, where are we? Yes, the next step, I guess, is, like I was saying, we're gonna have to write some... Firstly, how long have I been streaming? 46 minutes? Okay, let's see, because I have things to do, but let's see if I can get a character on the screen. So, I already knew, like you can see, it's starting up and the PPU is like getting totally cleared, so I assume when you hit the reset button, FCUX is like resetting the PPU state, which is going to disable rendering of pretty much everything. So I guess that's the first thing for me to try and check is, let's make sure the PPU is actually turned on. Again, I was trying to read up at least a little bit about this because I don't want to spend all day researching in front of you guys, so I have at least some idea of what needs to be done. Do I have PPU? So I think, so there's a handful of registers. Yeah, like I think this one you can pretty much write 0 to, and it doesn't matter, and it will be fine. Let's see. Base name table address. Offset 0 is at 2000. That's the one I want to use. Oh yeah, one of the things I know, it's just that the PPU is off because FCUX has a where is it? PPU. Oh, name table viewer. So this shows you what actual name tables are in PPU memory right now, which is what maps the character, the patterns from that pattern table we were looking at onto like the map that's on screen. So they're there. You can see there's garbage here, but it's garbage that is not being rendered. So I think the first thing we need to do is like turn the PPU on. Okay, so this first one, 0 is fine for that. VRAM address increment, I'm not going to be, well, no, I will be writing the PPU data, but 0 is probably fine. That just adds 1, and I will... It disconnected just so that I could throw the cat out. Let's see, sprite pattern table address for 8x8 sprites. I guess 0 is fine. I don't really care. We'll probably find out. Buddy. Buddy. Come here. Come here. Come here. I know you just want to crawl all over my projects. Okay. Anyway, so I have not really a good idea what those mean, but we'll figure it out. And again, 0 is probably fine. Sprite size 0 is 8x8 sprites. Don't care, I'm not doing sprites, so 0 is fine. PPU master slave select, I hear 0 is the proper value. And I do not want an NMI from the PPU right now, so let us start by just writing 0 to the register at 2000. Where are What do I even want? Yes, I want my assembler. Which you'd think at this point I could totally do by hand, but nah, man. Let's be really redundant and add another load A instruction, even though I have a load A0 right there. And store it to the register at 2000. Alright, that's that register handled. PPU mask. Wonder if this is another one that I can just write a 0 to. PPU mask, let us see. 0 is normal color, cool. 1 is show background in leftmost. That actually might be useful, but 0 is fine for now. Probably. We might need this for getting as many text characters on the screen as possible, but 0 is probably fine for those two. Oh, I do want to show the background. Crap, we're actually going to have to set a value for this. Okay, so that's going to be normal color, so 0. Why not set these to 1? So that'll be 0, 1, 1, 1. So that will be... What is that? That is F minus 1, so that's E. Okay, so our low nibble will be E, and we want to show sprites, so that will be a 1. I don't want to emphasize any of the colors, that will be 0, 0, 0. So our value should be 1E, if I'm thinking of that correctly, and that is for register 2001. Almost dropped the mic on myself. New mic setup, so a little bit chaotic. Anyway, what did I say? 1E? Yes. Store that at 2001. Next register. Render control. That sounds... Oh, right. That's going to render the background and show the sprites. I don't care about the status, which apparently is read-only. I don't care about OAM stuff because I'm not doing sprites. We'll see if I care about scroll stuff. And these are the registers for writing data from the CPU into PPU address space because they are separate address spaces. And this is for doing DMA. So I think that might be all we need to get things doing something. I keep forgetting. I want to go over here. So yeah, let's assemble that. Did it fail? I wasn't paying attention. Oh, because this $sign means hex value. Cool. Ensemble. Okay, and then you can watch me hand type this in like a maniac. Again. A9 00 8D 0020 A9 1E 8D 0120 A9 00 8D 0080 A9 01 8D 01 80 1890 FE. Zeros for good measure. For no good purpose. Alright, and let's reset this thing again and see if it does anything. I believe it has crashed. Okay. Let's see if that matches what it was showing us in the name table viewer. Well, would you look at that? We're actually rendering stuff. Sick. Okay, so now my next thing is I want to get an A on the screen. And then, I mean, I wonder if that's enough PPU initialization to just jam that onto the ROM and see if it does stuff. So, let's see really quick. We already had the... Oh no, that got janked up. Interesting. Why isn't my stuff mapped properly anymore? Oh, because I didn't... Right. because we didn't put 5E into the code over here. I changed it manually. Right. It was 1. Anyway, not a big deal, but reference to self. So that would be, let's see, 8D, 8001 is my write to the 8001 register, A901. So we need to replace this with 5E and reset again. There we go. We have keys on screen. That's pretty cool. But what I would like to do, and I'm going to need to figure out palette stuff too, but we'll get there. Because I kind of skimmed how palettes work, but I don't care so much about that just yet. But yeah, let's try and get an A in there, which will be tile 30. So I think all I need to do is write 30 to the PPU data register. Okay, yeah, I think I write the base address of the name table, which again is this bit of memory that maps patterns into the tiled map on screen. I put the base address of the name table, which I think I also have. Do I have the PPU memory map? 0 through FFF is the 0th pattern table. 1000 through 1FFF is the first pattern table. And those are, fun fact, what these two are. So this is that first chunk, and this is that second chunk. There's a reason they're in 2 chunks. There's like registers in the PPU that control what things use which chunk. But anyway, and then let's see. So name table 0, which should be that first one we're looking at, I think, starts at 2000, and that's what that one register setting was saying is like 2000 is the default value. Let's see. Yeah, because it looks like you can offset it if you want to. I don't know why you'd want to do that, but I'm not going to. And that 0 that we're writing into this register means that we already are not. So, I believe, let's see. So there's the PPU address register, and if I want to write into PPU memory, I write, okay, yeah. So you write, interesting, you write it in big endian order. So you write the first, the high order byte of the address that you want to write to, and then the low order of the address that you want to write to. So, let's do that. What was my, just 2000, right. So, before we jump into our loop, so let's just make note. This part, this first chunk is, let's use semicolon comments, we will find out. This is setting the basic PPU registers to render stuff. Set the MMC3 to map in the character set, kind of. Not the whole character set. And then finally, we will write a character to the first cell of name table 0, which should be as easy as load a 20, store that to, what is PPU address, 2006. And I almost forgot to make that hex again. And load a 00, store it to 2006. So that will give us our 2000 address in PPU memory. And then I believe we should just be able to write 30 to PPU data, and that will write 30 to PPU address 2000. Let us see.
VRAM read-write data register. After access, the video memory address will increment by an amount determined by that PPU register that we wrote a 0 to, which I believe causes it to increment by 1, so it will increment by a character, or a tile. It's probably some stuff you don't care about. Yeah. I don't think there's anything more interesting in this, so let's just go for it. Load a 30. Store it in. This was 2007, right? Yes. 2007. Okay. And we will hand assemble and hand input this again. Here, let's do this in a slightly less crappy way. Let's download the binary. Let's call this... I'm just going to call it temp for now because this is not code that we actually want to use, because it's not, this isn't being turned into actual cartridge code. This is stuff that I'm putting in by hand. And let me open this with, can I open it in, this will be hilarious if this works, honestly, in the XG Pro shitty hex editor. Go to the very beginning, which is where our code is going to be. Can I... It lets me copy. Can I know I can paste here, but will it, like, actually work? No? Did that do anything? That didn't do shit. Dang it, I thought that was going to be a lot easier. Well, fine, by hand it is. Let me write this in by hand, then I will review chat, then we will try and run it, and yeah, F it, I'll get it onto the ROM too, and we will see it if it actually does anything on real hardware. Okay, join me on this adventure. A9008D. Oh, my camera turned off a while ago, didn't it? Sorry. Where were we? 8D00209E8D008D008080A9, which I realize I am just writing the code that was already there pretty much. 5E8D. Yeah, I could have just appended to this. Oh well. I'm already typing. Too late. A920A908D0620A9. 30. We are getting there. 8D07201890 FE and a bunch of zeros for good luck. Okie doke. Reset. No. That did something weird. Because the name table is like offset up by 1 for some reason. Was? Did I type my code in wrong? Well, either way, let us review chat. Ocelot says, it's another Discord server I'll be in just to barely ever say anything. The excitement. Trust me, I understand. Just having bodies in there it makes me feel great. Real Yanush says, fascinating stuff. Shame I discovered your stream when I was heading to bed already. I'll make sure to watch the VOD tomorrow. No worries. You watch whenever you want. That is why I set the make this a VOD automatically thing to always on. Anyway, so it kind of looks like I scrolled this somehow, or maybe it just scrolled by dint of you know, I don't know, because it also keeps crashing. which I don't understand as I'm changing this code. Oh, probably because I'm overwriting the part where it's doing a loop and then it goes off into space. So, yeah, you can see this scrolled. This definitely scrolled. So, what shall I do? Oh, it did. Am I seeing that right? Shoot. Let's see. Let's make sure we reset the scroll thing, because I think I see an A there, but the name table viewer is way too small for me to tell, but I think that may have actually worked. PPU scroll. This register is used to change the scroll position. That is, to tell the PPU which pixel of the name table selected should be at the top left corner of the screen. Okay, so doesn't really say it there, but I think it said up here. Oh, interesting. So it takes two writes. You write the X scroll and then the Y scroll. Interesting. Well, I want them both to be 0, so let's write 0 twice to 2005. And then still see if I can paste this in, because typing that out is a pain in the butthole. Right, so as part of this... You know what? Let's be smart. We already have a 0 in A, so let's store it as well to... That was 2005. Twice. And... assemble. Okay. And download. The cat is coming. The cat is coming! Watch yourselves, for he is breaking everything. Yes, I would love to replace that file. Go for it. And... let me try... loading this file here. I could just get a better real hex editor, but that would take a minute, and I like hex. I like bad hex. So let us try. Selecting this, copying this, seeing if it will paste as a string to Notepad. No, what does this even do? It doesn't... It gives me the option to copy, but it doesn't actually seem to do anything. It probably just works internally in this application. Let's see. Yeah. Yup. Interesting. Okay, let's get a real hex editor. XVI32. Classic. I'm sure there are also way better Windows hex editors than this, but I have been using XVI32 for a million years. Where is the rate? And it's crappy, out-of-date website that has been terrible for like a decade. Let us extract all. Oh, this cat just wants some love. He just wants some love. Okay, let us open the temp bin. And... oh, I was totally saving that somewhere, wasn't I? Documents. It's just a PC, NES, temp bin. There it is. Okay. XVI32, don't you let me down. Yes? Come on, guys. Give me a friggin' break. You have a copy to clipboard option. Does it also only work internally for XVI32? Am I wasting everybody's time? Why? Yeah, it's not like just copying it as a string. Well, even though I know this won't work, let's try it anyway. Wow, look, it didn't work. Surprising. Okay, here we go. A9008080 208D 0520 8D 05 20A9 1E 8D. This is boring, even the cat. 0120A9 8D. He just wants to sniff the NES. 0080A9 5E 8D 0180A9 208D 06 20A9 008D 06 20A9 308D 07 2018 90 FE and some zeros for good luck. Okay, yet again. Hope I transcribed that right. I don't know how to respond to Redgeck's comment, who doesn't want to sniff the mess? Yes, we are a kitty household here. Nothing against puppies. I convinced my wife of the goodness of a cat, which is subjective, but we love our guy. Okay, reset, and nope, it is still messed up. Cool. Well, it has a debugger. Yeah, it is at some ludicrous address. F67F. How did it get there? I don't know. Fun. I guess we can put a breakpoint at FF40 and just step through it. See where it goes insane. Add breakpoint at FF40. Execute. Yes. Okay, and I think theoretically cool. It stopped at FF40. So let's step and see where it loses mind. Well, firstly, I should be able to see if there's anything. Oh, yep, something screwed up here because it has a break instruction here, and that ain't right. So I definitely typed in something wrong. Let us compare this to the source that is in the browser. I mean, I guess I can just compare bytes, right? A900 8D00 20 8D05 20 A9 1E 8D01 20 A9. Oh, I've already lost my space. 0120 A9. There is supposed to be a 0 right here. A9 8D00 80 A9 5E 8D01 80 A9 20, 8D, 06, 20A9, 00, 8D, 06, 20A9, 308D, 07, 201, 89, shit, 90, FE0 for good luck. That felt righter. However, it still sucks. Come on, man. This is why this is not at all a tenable way of doing this. So how is this disassembling it? Oh! Wait, is it because I have a breakpoint here? Tis. Still scrolling the thing, though, which is odd. Fascinating. Yeah, it's still scrolled. But I am damn sure that is an A there. Right up in the corner. You cannot tell, but it looks very A-like. So, what am I doing wrong with the scroll? I don't even know. Does anybody have any idea? No. Nobody has an idea. But I would really like to get something on the ROM before I sign off. But it has also been close to an hour and a half. Hum. It's got to be something like... Well, no, it said that scroll determines what pixel it starts at. And, I mean, reviewing this assembly, it sets A to 0, 0, and then writes 0 to the scroll for X, writes 0 to the scroll for Y. Loads 1E, sets the PPU mask thing to 1E, which is what turns on the rendering and whatnot, then loads 0 again, writes that into the mapper. For controlling stuff, writes 5E into the mapper to select the 5E bank on the thing. Then sets 2000, sends that to the PPU address register to write 30 to the PPU data register, clears carry, and then branches if carry clear to FF6A, which is this line, so that all looks correct. So I am clearly not understanding something. Let me look at the notes, because it now occurs to me I think it was trying to tell me something about Y scrolling, and I just didn't read it. That's the memory map. PPU scroll. Let's see. Horizontal offsets range from 0 to 255. Normal vertical offsets range from 0 to 239. While values of 240 to 255 are treated as -16 through -1 in a way. But tile data is incorrectly... Okay. That still sounds like 0 should be 0. Huh. Well, for fun, what is 240... What is 241? X. Decimal 241. That is F1. So, let us, for fun, change the... frick. Well, there's where trying to be a little more clever bites me. So, in order to not keep setting A, I wrote a 0 to it right here and used it for writing both 2000 and 2005. So I need to scooch this all down. Damn it. You know what I can do? You know what's the easiest way to just append some stuff? Is I will... I know the code is going to be A9 F1. That's load A F1 immediate. And this is one nice thing about branches, is since they're relative, I can move this wherever and it will still just... That's a branch no matter where it is in memory. A halt loop no matter where it is in memory. So I should just be able to scoot that down. And we will just write the scroll registers again. Yeah. That seems like the way to go. So let's... oh, so I need to look at what store A is. Store A to address is going to be A900. It looks like it is 8D and then the address. So let's do A9 F1 and oh shoot, actually A900 because we still want the horizontal to be 0, and then that was 8D, and our address is 2005, so 0520. Then load A9 again, or load the address with A9, the A9 opcode again, but now we want to load it with F1, and then we will store that to 2005, so another 8D 0520. And then we can do the halt loop again, 90FE. And that is how you hot patch machine code. That sure did something. Oh, it did negative scroll like they were saying. That is an A right there. That is definitely the top of memory. And yeah, you can kind of see this isn't rendering it very well, but yeah, they were saying they can be used as like negative values, but it will render the tiles wrong. That looks like what is happening. So I guess I need a negative scroll, because I think it's gonna like clip off some of those. Anyway, that's good enough for me. Let me just move that around. I will just update that in this code, and we will also make this code into an actual ROM image that I can put on my EEPROM and boot it and see what happens. So the change we need to do here is our first rate can still be 0 there, but then we need to load a I don't know. Let's do F1. Why not? I just want to be able to see that A, man. That's all I care about. And cool, and then that's the Y right. Excellent. And all we have to change here is to just move this into our actual ROM instead of being at the beginning of memory, because I only set it at the very beginning of memory in this assembler so that it would be right at the top, so I could grab it and copy it into the working memory of the emulator. So we do fill, then we're gonna make our entry point label. Oh, let's add these two. And again, I really don't need the org, but whatever. And it would be fun just to keep that in here. Maybe I will. Maybe I will. Yeah, you know what? Let's replace our simple halt with the one from earlier that reflects the state of the controller input. Yes. And then, let's see, our entry point is called entry, which is what I have on my clipboard, right? Yes, it is. Okay. So, that is patched up enough now that I should be able to just turn this into a ROM and write it to the EEPROM and see if it boots. See, because I'm not sure if there's a palette set either, so
This may just not work. Whoops. We'll call this the win for today. If doing it on hardware doesn't quite work, then that's not the goal I'm setting for myself. Okay. That's just line wrapping. I scared myself for a second. All right, so we're gonna jump to entry. Entry is now at E1000. We clear our interrupts and make sure it's not in decimal mode. Then we do all of the PPU setup that we were just playing with. Write the A to the PPU memory, and then do our halt loop that is echoing the controller status, because why the frick not? All right. Assemble. Download binary. Generate. Save. And let's, I don't know, call this show an A dot bin. Bin. Take it to XVI, not XVI32, XG Pro. Load it. Browse. Show an A. Do that. Offset, as always. Okie dokie. That is ready to go. Let us change to a different angle, because we haven't seen a different angle all day. There we go. I want you to witness me pulling this EEPROM back out of the cartridge. Yeah, I'm a big seems good enough, send it kind of person. Does it work? Yeah, go for it. Is it the ADHD? I don't know.